something you can work on while I follow the road. See if anybody can get that line.
It's a maybe. It's a maybe.
Jackson, where's Jackson? Is out here? King.
Here. You said King?
King.
King, K-I-N-G?
Yolanda King.
Yes, that's the mayor, sorry.
Is she?
Yes.
Lindsay.
Here.
Nelson, not here. Moreland. Moreland. I guess you dog. David, you're here. Hipper's not here. Raby, back to you're here. Ray, not here. Robert, you're back here. Smith. Yeah, I need to, yeah, you, ooh. You need to say, I need to see you, so. And what I have absent, Jackson, Belton, Moreland, Pippin, Ray. Everybody else I have here, so. Anybody get the area of that triangle?
Not yet.
Should be a pretty easy one to do. Did anybody do that one? Has anybody got the answer?
Can you write in a darker color next time?
What?
Right, can you write in another color next time? Like the darker pen or something? How am I gonna see the problem? I can't see it.
You have to get out a piece of paper and pencil, you all to work it.
Well, we don't see it first.
Has anybody got the answer to it? Anybody know how to do it?
Give us a second.
I just thought of this when on the way over here, and thinking, why not pitch it back out there?
You get the degrees.
Because it's there's certainly an easy way to do it. Well, it's an easy way to do that, but there's several ways you could do it. One way you would need trigonometry You know, I'm not asking you to do it using trigonometry because that's not what this class is about. But you could use trigonometry to do that problem, but we don't have to. It's much easier than that. Anybody get it? No? Y'all listen a second. You notice that these are all what? These are tangent, right?
Yeah.
So when they are tangent, these points do what? They connect, and this distance right here would be what? This would be 80. This distance right here would be what? Would be 50. And that distance right there would be what? 70. Now, does that make sense? Now from that should be an easy thing to do from that point up. Y'all still see how to do it? They were one way right now for you all to do it besides trigonometry. You don't need trigonometry.
The triangle area, why not?
Pythagorean theorem.
Don't leave Columbus Tech thinking that Pythagorean theorem works on every triangle. Pythagorean theorem only works on what? 90 right triangles. Anybody got it yet? Nobody got it? It is this. You should know this. You should remember this. Because as much as I talked about it, that's the answer right there. Y'all don't remember that. How many remember that? They even told you a story about it, right? Oh? Who remembers? Y'all don't remember this?
No.
Y'all remember me telling you about this? This guy? Remember that? Hero's formula?
Yeah.
That it was around for a long time, for several thousand years before they even knew how he came up with it. It is really to find the area of any triangle that you know the length of all three sides, and it is this. And it wasn't until a couple thousand years after the fact that they figured out that what he did was correct. But they used this for a couple thousand years, never knowing how it came about. And the way you get S, everybody, is you just add all the legs together and divide it by 2. Y'all ever do that? S is equal to what? A plus B plus C divided by 2. I think this is 200. Divided by 2 is what? 100. So S, there's 100. That's for S. That's 100 minus 80. That's A. Then 100 minus what? B, which is 50, times what? 100 minus 70, which is C. Do that calculation, and you got the area of that triangle. That's pretty nifty. It's something that you need to know. I mean, you should you should remember some of these things, you know, just for the sake of knowing that you can, in fact, find the area of a triangle just by knowing the length of all three legs. You can do it two ways. You can actually use trigonometry to get the angles. You can find every single angle in that problem using trigonometry. But we're not using trigonometry, we're using what? Just basic algebra. And this is an algebra problem that I know you covered in Math 1111. This one right here was in Math 1111. A couple of different places. So, actually it's Heron that did it, but they nicknamed him Hero. Hero's formula. Isn't that easy to remember though? Easy enough to remember? Or if nothing else, you should remember what? Yes, there's a way to get the area of a triangle if you know the length of all three legs. That's what's important. Because most people wouldn't know that. Most people, when you ask somebody, if I gave you this triangle, tell me the area, what would they do? I wouldn't know what to do. I don't know. But if you do know that if you've been given all three legs of any triangle, at 90 right or not 90 right, doesn't matter. That will work on a what? On a 90 right triangle also. But it works on all of them. But it's neat to know that if you've been given a triangle with the length of all three legs, then you can in fact do what? Find its area. Of course, you don't have to know this for this course, but you can also use trigonometry to do what? Get the angles, and with all three of those angles you can get using trigonometry.
That was from the last class.
This way?
That was from the last class?
Yeah, I don't think that's for me.
No.
I didn't do that. How about if you did this? What if you asked this question? I want you to find
Today.
Well, could you read that?
No.
But you need glasses.
No.
I would read that.
It's like microscopic.
I can read it.
I can read it from here.
Well, let me
and
use
even
some of y'all
farther
health
back.
insurance so I can give you some glasses.
Y'all read it?
Yeah.
Yeah.
It says find an equation of a circle given its center point is -4, 3, and a point on the circle is -8, 10.
Okay.
Add your solution to a circle. Uh-huh. Got it? You got it, Ed? Everybody got it?
I got an answer and tell me it's wrong.
Let's see. Think about what you just did.
What do you mean?
Before you get too carried away with what you're doing, this is what I want you to think about. In order for you to write an equation of a circle, you must know two things about that circle. You must know its center point and the radius. If you know the center point and radius, then the equation for the circle comes just that quickly. It comes just that quickly. You have to, listen, you have to know the center point, and do you know the center point here?
Yes.
And you have to know the radius. If you know those two values, then writing the equation of the circle is just almost filling in the blanks and just doing the arithmetic. Y'all remember doing that?
Yes.
Okay, I'm going to ask you again. Do you know the center point?
Yes. Yeah.
Yes. Do you know the radius?
Yes.
Well, you can find it.
What?
You can find it.
Well, I'm glad you got the right answer, because he said you can find it. You don't know it, but you can certainly do what? Find it. How would you find the radius of that circle?
Distance.
How would you find the radius of the circle that I have on the board?
You can either make a graph or use the distance formula.
It's what?
You can either draw a graph or use the distance formula.
Well, you have to use the what?
Distance formula.
The distance formula. The distance between those 2 points
Yeah, you
will give you the radius, because you have the radius, you have the center point, you have a point on that circle.
yeah, but you can use the Pythagorean theorem too. You can use Pythagorean theorem on it. If you draw a picture and you draw the point on the line and you connect both those points, then you come down like you're drawing a slope line. You can use Pythagorean theorem on it. I'm not trying to give away like shortcuts and stuff, I'm just saying you could.
Trying to make them use the distance formula. The distance formula is nothing more than what? Pythagorean's theorem, right? Y'all remember me telling you that? It's just the Pythagorean theorem. What's the distance formula? Somebody tell me quickly.
X minus H.
It's the square root of,
Y2 minus Y1 plus X2 minus X1 squared.
Yeah,
We're
just
gonna use the X minus H.
the difference in the x is squared plus the difference in the y squared. That's so easy. So easy. So once you know the center point, which we know, look at this, everybody. That's better. That's the center point right there. And you've got a eight comma what, 10? Remember now, that point is what? That point is over the circle, right? So this would be the radius. That would be the radius right there. So you have to get the radius is what? The distance between the 2 points is, this point is minus 4, comma 3. So it is 8 minus a minus 4 squared plus 10 minus 3 squared. So the distance is going to be equal
It's negative
to
8.
the square root of 12 squared plus 7 squared. Distance is going to be equal to the square root of 144 plus 49. The distance is going to be equal to...
No, it's not. Hey,
It's supposed to be negative.
it's a -8.
This what?
It's a -8.
You were big enough for us to see, we didn't know that, we told you
That
that
should have been
earlier.
a negative 8. That would make that what?
It's a 4.
That makes this a 4, right?
Yeah.
Makes this a 16 plus 49. How about your 16 plus, that's,
65.
how much?
65.
55?
65.
65.
You're about to let me see.
Now, I would leave that problem as the square root of 65. And as you'll see a little bit later, that would be the way I'd leave it, because the equation of a circle is this, everybody. It is x
Minus 8 squared.
plus 4 squared plus y minus 3 squared equals to the square root of 65 squared. Everybody see that? You see why I left it as a square root? Because when I square the square root, I just get what's under it. I don't try to simplify it. So this now becomes x squared plus 8x plus 16 plus y squared minus 6y plus 9 equals to 65. Now this becomes x squared plus y squared. Now the first thing that comes up is a plus 8x minus 6y. Now this is plus 16 and 9 is 25. Minus 65 equals 0. I put this over here. The answer now becomes x squared plus y squared plus 8x minus 6y. This is how much? 65, 50. What about, that's minus, somebody do that arithmetic for me. 40? Did I do the arithmetic correct? Right here.
Yeah.
See, look, the equation of a circle is always going to be this, everybody. It is x minus h squared plus y minus k squared equals to the radius squared. That's just standard equation of a circle, where h and k is the center point. Now, if h and k was 0, 0, then this would become x squared plus y squared is equal to r squared, which is nothing more than what? Pythagorean's theorem. That's the same thing as saying what? A squared plus b squared is equal to what? C squared. Everybody see that? This is the same exact equation. Because you know just from doing this problem that what? That a circle is nothing more than what? That's a 90 right triangle, that's a 90 right triangle. This is a 90 right triangle. That's the 90 right triangle. So you got what? You got infinite number of 90 right triangles makes up a circle. Instead of calling it a squared plus b squared is equal c squared, we call this x, we call this y. That's the radius of the circle. So x squared plus y squared is equal to what? R squared. X squared plus y squared is equal to r squared. That is provided that the center point is at 0, 0. But if it's not at 0, 0, you will know that because of this jump right here. You see this? This is telling you it is offset somewhere on the graph. That make sense, everybody?
What chapter is it?
Huh?
What chapter? 2? What chapter?
That comes out of chapter 2, I think, but that actually comes from the fact that chapter 2 deals with what? The distance formula, the linear equations, and this being what the distance formula here, and I just made up a problem in which you would need to know how to do the distance formula. That would be a good enough reason to want to know the distance between 2 points. Does that not make sense? You would really need to know the distance between those 2 points, simply because why? You would need to know the radius of that circle. I mean, you can teach distance between 2 points until you're blue in the face. But until the students see a need for it, they're not going to worry about it. So I know how to find the distance between 2 points. Big deal. What good is that? Well, you just saw an example of where you have to know the distance between those 2 points. It's not like I wish I knew, it's I have to know in order to work the problem. Because you can't work that problem, you cannot get the equation of a circle unless you know at least 2 things about it. That is the center point and the radius. And I only gave you what? I only gave you the center point. You had to first of all go out and find what? The radius. And then once you found the radius, which was this, then you could go do what? You could now plug these in to the proper place. And this just says do what? It says to take this binomial and square this binomial. You see this? It says square this binomial. And folks, let me tell you, if you're not able by now to square a binomial of this size, in this magnitude, as small as it is, and as simple as this is, if you can't do this in your head, then you need to go to the lab, and you need to go light some midnight oil or something, and sit down until you do what?
Get it.
Now, all of them, I don't care if you learn to do all of them, but simple ones like this, folks, you should know that that's x squared plus 8x plus 16. Only looking at it one time and doing that quickly in your head. If you're not able to do that with a binomial, then work on it, whatever you do. You don't have to know, but it just makes life so much easier if you can look at this and say, that's y squared minus 6y plus 9. Just that simple. There's two of these. You can put two of these together. A minus 3y and a minus 3y ain't hard to remember this minus 6y. And a y times y is y squared, and a 3 times 3, which the minus is both up minus, makes a plus 9. That's really simple to do. So get to that point of the game to where you can do that mentally to save yourself some what? Lots and lots and lots of time. Just like this. I just walked by this young lady a while ago, and she was working away with these problems, trying to find a common solution. And she spent countless minutes working on this problem, trying to eliminate all the variables and all this stuff. And I saw what she did. I said, why don't you do something really quickly? Why don't you learn to do this mentally? And she flipped out when I showed it to her a second ago. I said, why don't you multiply this times this, and you get a 6. I mean, you get a what? You get a 12, right? If you multiply this times this, you get a 12. And if you multiply back this direction, you get a plus 12. You change it to minus. And now you can quit. You don't have to worry about doing anything else for that problem. Why?
Because you've got the answer.
And what is the answer? What is the answer? What you said? What is? You got the answer. What is the answer?
We can't do it mentally.
No, you don't have the answer. You don't have the answer. So, stop guessing.
Give us a second, we got it, hold on.
Hell, the reason you can quit is because these are parallel. Period. So, instead of her worrying about doing what? Eliminating one of these variables, and she was going through all these steps, she could have very quickly and easily done this. I said, if you get a 0, you can quit. Just quit if you get a 0. Because there's no solution. Because the lines are either the same line or they're parallel. That makes sense? Can you look at those and say they're parallel? No, you can't. You can't just look at them and say those two lines are parallel. But I know now that they're what? Because I got a 0, that they are parallel lines. or they're the same line. They're on top of each other, or they're parallel. She was thrilled because now she realizes there's a lot of times she was working through a bunch of problems and didn't know what to do when she couldn't get an answer. Why couldn't she get an answer? Well, hell, they don't have an answer because they know what? There's no common solution. No real solution. Because they don't cross each other. If you get a number, you don't care about the number, whatever it is. I don't care what number it is. It's just what? It just tells me that there is a solution if you get a number. And see, I sort of fault the books and instructors and everybody else. When you are teaching systems of equations, that's one of the first things you should teach them. To quickly do what?
Determine whether or not there's a solution.
Find that. It's called a determinant. I just did a determinant. Do that determinant really quickly. And if you get a 0, quit. Quit wasting your time on that problem because that's all you're doing. Nobody ever told her that. Nobody ever stopped long enough to show her that. I think that's a must that you. Now, I don't know how many of you will remember that, but at least I told you. Now that you know if two lines are parallel or not, what if they're not parallel? That means they do what? They cross each other. How do you know if they cross each other at 90 right angles?
Their slopes are opposite, inverses. Opposite inverse, the slopes.
Their
Slopes are opposite inverses.
They're opposite in sign and what? Reciprocal.
Yeah.
Reciprocal. In other words, if you multiply the two slopes together, you'll get a -1. If that happens, then you know they're what? They are perpendicular lines. Write the equation of a line that goes through these 2 points. Write the equation of a line that goes through those 2 points. Everybody got it finished?
Yeah.
Anybody not finished? Miss Bradley, what'd you get? Stop writing down. Cause I think I've wasted my breath teaching the class, really. Nobody starts to do any work and kind of walk around, and then they pick up their pencils and start doing the work, so. If y'all gonna do something else, I just feel like I'm wasting my time.
Do you want the answer? Do you want
No, I don't want it.
Okay.
I have it.
Y was negative 2/3, so it's like 2/3.
Yep. I had it.
See what we can come up with this problem here. We could probably say that this is a cost function, right? This is a cost function in reference to X. And you can say, well, what could X be? X could be the number of machines that you're taking care of, okay? And this could represent the cost of maintenance. If you wanted to call it, you could say C sub X could be the cost of machines, okay? And X being what? The number of machines you're taking care of. In other words, the number of machines you're running in your company. And this is the cost that you are looking at per machine. So this being what? X being the number of machines. And somebody has come into your company and they actually go in and they do a mathematical modeling of your company, and it's producing. They can tell you some different ways that you can cut cost, but this could be what? A cost function representing the cost of what it's taking to run your machines. How many machines do you have? X number of machines. They didn't tell you what X was. My question would be, what is going to be your minimum cost? What is going to be your minimum cost for those machines? What is your minimum cost going to be for those machines?
You want the answer? You want the answer?
You already got it? Yeah.
$4,628.
I don't know the answer.
Hey.
I expect y'all to work it out and give me the answer. We'll hold up and see if you got it.
that's what I was about to say.
That probably sounds right.
No, that's way off.
Way off.
Way off. I think I got it now though.
Got it now?
I think so.
Okay. Everybody else got it?
Working on it. Wow, this is pretty crazy. I do the quadratic formula.
That's actually.
Yeah, it's 35.
That's okay.
Yeah.
That and
That's it?
Nonsense.
You all recognize Mr. Wilson has in the back, he is also calculating how many machines he has to work with to minimize his cost.
We don't have a clue.
I don't have a clue. I don't know how to help you.
Is there a formula that we use?
Don't get it?
It's what?
Get it? Get it? What are you gonna do with it?
We don't know.
No, I'm not.
Well, you should know.
I reduced my.
Mr. Wilson knows.
Well, Mr. Wilson is one damn team.
Wilson's been listed.
You can't win a sport with only one star.
Maybe you get 217.
Mr. Wilson's been listed. What do you get?
She ain't even got the mark. Nobody has a clue.
Get in there. What do you get?
She ain't got a clue.
At least I'm working.
I don't believe in wasting.
You don't even have pencil paper.
Hurt.
Got it?
Whose ringtone was that?
Got it?
Honestly, looking at it,
It doesn't.
Mr. Wilson, tell them how you got the problem and how simple it is.
Go up there, Mr. Wilson.
The vertex.
You just found the damn vertex. I mean, this is a quadratic. It looks like this, everybody. It looks like this. You know what? If it looks like this, there's got to be a minimum point somewhere, right? He just found that minimum point by finding the vertex. Now, how many times have I had y'all find the vertex in this room? Only ask you to do it a half a time, one time. Half of a time. One half of a time. But no, I've asked you to do it what? 7, 8, 5, 15, 25 times? 20 what? 20 times?
Can you work the problem out?
No, I'm not gonna work it out. You work it out.
Okay. Well, I paid my tuition for it.
If you don't know how to find the vertex, you better start learning. Because we've done this too many times. And I'm not going to go over it again. It'd be different if I'd never gone over it before, but Mr. Wilson, how many times have I gone over the vertex?
At least 1,000.
No, it was only 996. Wasn't over 1,000. Only 996 times. Hell, that's a lie. Over 1,000 my foot.
So we still wrong.
Really though, does that make sense to everybody? If that's a what?
Parabola.
It's like this. There's got to be a minimum point, and you are trying to find that minimum point. And he found out that when you have what? 33 machines. If you got 33 machines, that's going to produce the what? The minimum cost for you. You put more machines to work, it's going to do what? Cost more. you do less machines, it's gonna cost you more, because it does what? It goes up. There is a, it does like this. This point right here is 0. I'll take that back.
I got it.
Like this. This point is 0, 24, 50. This is 33. Was it 33?
Yes,
Did you get 33 as the first number of the vertex?
yes.
And what was the second number of the vertex? It's probably somewhere up here, wasn't it?
272.
Yeah, it never touches the x-axis.
So it does this number like this, everybody.
So you can't even use quadratic.
That's
formula.
33. This point right here is 0, 24, 50. And it never does do what? Never does cross the x-axis.
Yeah, so like factoring it or the quadratic formula would have been a waste of time.
Is what now?
So if you use the quadratic formula or tried to factor it,
It would have, yeah, if you try to factor to use the quadratic formula, you'd have gotten imaginary values.
yeah, it would have been.
Which says that
it
the
didn't-
solution says imaginary, because the vertex is way up here. It's not even touching, doesn't even come close to the x-axis.
Yeah.
Ah, okay. Any other questions about that?
How did you get the 33? How did you get the 33?
Negative B over 2.
Oh, negative b over 2a.
Okay.
Remember that?
Yes, sir.
That's the first number of the vertex, always. Negative b divided by 2a. So that would be what? That would be 132 divided by 4. That's 33.
Okay.
Got that? That's the first number, so as you go to 33, and you plug the 33 back into the equation, it gets you this point right here. I don't remember, what did you get for this point? You got 33, what was it?
272. 272.
272. Everybody see that?
Where's that second number coming from, the 272?
Yeah.
How you get it?
How'd you get what now?
How you get 272?
You put the 33 back into your equation.
Yeah.
Okay.
What's that 272 tell us again?
That's what the answer is.
That's the y value.
So we plug in we plug in the 33 for x every time, and that's how we get the 272?
What was that tell us about the computer? Like that's the lowest point. So and if your
That's the lowest cost.
And y is the profit.
If it's dollars, it's $272 is your minimum cost.
For 30.
If you, look, if you put less machines than 33, it's gonna cost you more money. If you put more machines than 33, it's gonna cost you what? More money. Does that make sense? See this right here? If you put fewer machines, it's gonna be more money. If you put more machines, it's gonna be what? More money. That point is the minimum point right there. You will not get a lower number than 272. Does that help you make it make sense? How could you say that was a cost function? Well,
Yeah, the minimum and that.
the thing about it is, it certainly wouldn't be this, right? It certainly couldn't possibly be that,
No.
because that would be what?
See that?
This would be what? A profit function.
Yeah.
The profit function looks like what? It's shaped like this. It's a quadratic shaped like this. And you see this plus 2,400?
Mhm.
Would that be there on a profit function?
No.
No. That would not be there. That would be what?
In a cost function.
That would be a minus.
Oh, yeah.
Because it says what? If you built and made machines, then if you made no machines, if you made no bicycles at all, then if that was $2,450, I wouldn't make any bicycles. I'd sit down and quit. Because that would say I'd be making $2,450 a day doing nothing. That make sense at all?
Yeah.
You know that this would have to be minus. This would have to be minus to be a profit function. Because you're trying to maximize your profits, not minimize your profits. We were talking a couple of days ago about functions and making an equation a function. And of course, this equation was a cost function. And it was what? It was cost and represented to x, the x value. Okay? So cost is a function of x. Other problems that you run into, and we happen to be studying the same thing right now in the college algebra class. We're studying functions, how to go about writing a function. And one of the example problems was something like this. It's quite obvious that if this is like a cone, and you turn this on and you let water or something go into this cone, it's going to do what? A lot of things are going to happen. Unlike a what? Unlike a bucket like this, if you got this spigot going on right here, only a couple things can happen here, and that is what? The volume and the weight of the water, I guess, if he's wanted to say, could be what? Would go up. And the height of the water would go up. Only two things that you can talk about happening in that situation. But what happens in this situation? You got what? Not only is the height changing, but the volume is changing. Not only is the volume changing, but what? The radius of this circle is changing. The circumference of this circle is changing. The area of the circle is changing. And all these changes are going on in this problem. So, if you looked at this problem like this, if you said this was 2, and we'll make it whatever we want to make it in a minute, but it could be 2 feet, and this could be what? Let's make this 4 feet. We'll make it an easy problem. we will call this little r and that little h. What do you see when you look at that problem that you're looking at here? What you should see is this. You should actually see something that looks just like this. Does everybody see that? That's what you should see. Even though this looks what? This looks three-dimensional. If you put this out on a piece of paper, it would look like what? Just a 90-right triangle. And if you have this like this, everybody, what do you know that you can do automatically when you have something called simular triangles? And those triangles are similar. What are they called when the triangles are exactly the same? They're called congruent triangles. But those are not congruent because you got a small triangle and you got a big triangle. So when you see this, it doesn't really matter how you go about doing it. You can do it several ways. And that is, you could say capital R is to little r as capital H is to what? Little h. It doesn't matter how you do that. You could say what? Little r is to big H as little h is to big R. I don't, it doesn't matter as long as you do it consistently and the same format. Does everybody see what we did there? Now, with this picture that we have over here, we know that this is what? 2, and this is what? 4. What they could ask you to do is they could say something like this. Write the volume of that ice cream cone